How the exponents deal with this number is, what the exponents do to the base number is basically broken down into the real number set, this whole thing here. So basically break it down to these 4 subsections, and that way you'll remember how to apply any number put here to the base. Now if you take the natural numbers, if you had the main, your base number here, and you had a natural number in the small box, so for example if you had number 3 in the small box and number 5 in the big box in the base, so that would have been 5 to the power of 3. The way that works is, in the natural number set, what that does, clones it. So when you put a 3 in the small box and a 5 in the big box, what that does is it says multiply 5 together 3 times. So what happens is it goes 5 times 5 times 5. Okay, and that's the natural numbers. So for example, if you had the number 2, okay, now this is on the base level. If we take another number and put it up here, let's say 2 cubed, what this means, this number here does, it means it's taking this number and multiplying it by itself 3 times. So it's basically telling you to clone itself 3 times and multiply it all together. So this number here and this number do not directly interact with each other. This number up here means you have to do things to this number. So 2 cubed would mean 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay. One of the biggest mistakes that people make is when they see this, they go 2 times 3 and they think it's 6. That's not the case. This number and this number do not directly interact with each other. They do not directly work together. This number does things to this number. So for example, if you had 5 squared, 5 squared would be 5 times 5, which is 25. Okay, straight up. And this also works if it's just symbols. So for example, if you had, are we still on? We're still on. If you had, let's say, a 2a squared. Now, when you have exponents, whatever's inside the bracket, this applies to them. Okay, so if you wanted to break this down, this would be, where we got get up to there, this would be 2 squared times a squared, because when you write 2a, it really means just 2 times it. So this is, I guess, a distributive property where it applies to this and this. So 2 squared would be 4, and a squared is just a squared. Okay, pretty simple, right? Now, this is for multiplication. For division, it works the same way. Let's grab another chalk. For division, it works the same way. For example, if you had, let's do the same thing, 2 over a squared. Can you see the orange? Yeah, you can see the orange. So 2 over a squared, again, this distributes to this and this. So this would be 2 squared over a squared, and 2 squared is just 4, and a squared is just a squared. Okay, easy? Yep. Let's continue with this. Let's move the camera over. Now let's talk about addition and multiplication, addition and subtraction. Okay. Addition and subtraction, when you're squaring things or cubing things, it's a lot more complicated, because the addition and subtraction we talked about before in the first series, it breaks numbers apart. So it's one term, but the addition and subtraction throws things off. Multiplication and division are usually way easier than addition. So let's say you had a plus 2 squared. Now, you can't add these because that's a letter and that's a number. What you have to do with these guys is, the squared term basically means this, whatever's inside the bracket times itself. You gotta go a plus 2 times a plus 2. Because the squared terms means whatever's in here multiplied by itself again. If this was cubed, it would have been a plus 2 times a plus 2 times a plus 2. And that's way longer. I might do one actually just to show you guys. The higher this goes, the more complicated it becomes. The more terms you get. That goes into the binomial distribution, which is sort of a formula you can apply. Once we get into things, we'll deal with that. But the highest we're going to take things for now is going to be squared, because I don't want to work out the whole thing. And the way this works, let's take a look at this. So this becomes a plus 2 times a plus 2. What this means is, this is what they call FOIL. Okay. FOIL stands for the first two numbers multiply each other, the outside numbers multiply each other, the inside numbers multiply each other, and the last numbers multiply each other. I actually had no idea what this meant until like about 4 years ago, 5 years ago. I never thought of it that way. I like more visual stuff. So the way I do it is, this multiplies this, this multiplies this, this multiplies this, and this multiplies this. Okay? A times A is going to be A squared. A times 2 is going to be 2A. 2 times A is going to be 2A. And 2 times 2 is going to be 4. Yes, 4. And the way this works is you got to combine like terms. Now I haven't talked about this. We're going to introduce it. Where I make the other video first and put it before this. Okay. So A squared cannot add with any of these because that's a square term. 2A plus 2A is going to be 4A. So if you combine those, 2 apples plus 2 apples is 4 apples, right? And 4 is just 4. So the answer to this whole thing is going to be A squared plus 4A plus 4. Okay? And that's how you do squares, powers, when it comes to letters and numbers being added and subtracted together. And that's the natural numbers. The next level up is the whole numbers, and all that did was introduce the number 0. And the way the number 0 works is, if you have anything in this box, it doesn't make a difference. It could be, WZ squared over Q, 100 in the front, all to the power of something else, blah, 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 square rooted. Doesn't make a difference what goes in that box. If you have anything in that box to the power of 0, it equals 1. Okay? So if you had a 5 in the big box and 0 in the little box, that would be equal 1. It doesn't make a difference what goes in the big box. Anything to the power of 0, I'm just going to put this up there, anything to the power of 0 is 1. So if you had a to the power of 0, that's 1. Doesn't make a difference what it is. You can add a bracket here and fill it up with anything you want. Letters, numbers, W, Z, 10, 100. Put it all to the power of 0, and the answer is 1. Okay? Anything to the power of 0 is 1. So that takes care of whole numbers. For the integers, if you go one level above the rational numbers, or one level above the whole numbers, you get integers. Integers do negative numbers. Okay, so they introduce negative whole numbers. So when you have your natural numbers here, we went up to the whole numbers introduce 0, anything to the power of 0 is 1. Now, if you put a negative number in the little box up there, what it does to the big box, it flips it. So